All right. Welcome to another science video by Johnny, and here we are working on one-on-one lesson. So Mr. N is doing science, in particular chemistry. Right. So okay, you are going through the concepts of working in chemistry, right? Okay, just go through
Yes.
it. Just go through it slowly.
What is chemistry? Chemistry is the branch of
It's a branch of
science
science.
that deals with the identification of the substance of which matter is composed, the investigation of their properties, and the way
In
in
which they
which they
interact.
interact,
Combine and change.
combine, and the use of these processes to form new substance. See, think, wonder. Analyze the image and add to the chart below by answering the question to sample have been complete as a guide. Add your thought to your notebook. What you see? What are you
Sample entry
thinking?
test
What are
tube.
you wondering about?
Experiment
Sample
in the
entry.
lab.
Test tube. Experiment in the lab. What are they creating? Sample entry.
Atom models.
Atom models. Where are they used? How does it all come together?
Okay, your turn, and they ask you for your turn. What do you see there?
There's like all these chart on the
It's called periodic table.
periodic
It's
table.
called
Yeah,
periodic table. Yes.
periodic table.
Wait. So this
Um,
is it the first time you into science into chemistry?
yeah, first time.
Oh wow.
Well, well, I but I heard about it in like in last grade, but didn't
Hmm.
really experiment
So it's not
it too
exactly
much.
first time though.
Yeah,
You have to say no.
um,
You have to say no. It's not the first time.
well, it's not first time, but yeah,
Not the last time either.
yeah. What are you thinking?
So when you look at a periodic table, what can you say?
I say, what are all the letters for to use?
Then you write it down. What are the letters used for, and
Yeah,
how their interactions are? Are they related in any way? How do you
yeah,
combine them? I mean, how do you put them in the order or something? It's like sometimes they
yeah.
don't. It's not random, right? It's put in a table for a reason.
It's
There's a
like
reason
put
to
it in.
everything.
So, what am I wondering about is what does the periodic table, what's the meaning of the periodic table and how to use it?
Exactly. All right, let's move on to action.
Finding
Finding
memory in your.
members.
So, remember the focus of this course on ecological concern has some to your attention. You have decide to learn more and share what you learn about issue on your blog. For learning activity, your goal is to create a team of people you learn about your
Ecological
ecological
concern.
concern. You start by researching your ecological concern and finding another person in your
Online or
online
physical
or
community.
who is passionate
Passionate about
about
the same ecological concern.
e.g. an environment lawyer, political community activist.
Activist, media personality, like, celebrity.
Yeah, like famous people. The person you choose should be someone who could
Right.
help you understand ecological issue. You may find the following resource and tutorial helpful if you are searching for a
Like
team
team
member
member
online.
online.
So these are like the
Okay.
stuff.
Hmm.
Chemistry careers. Careers involving chemistry are found in research, manufacturing,
Manufacturing, resource extraction. Because there's a lot
biology,
of related field.
biology, medicine, environmental, law, and even finance. Now it's time to learn about some different chemistry careers and consider what kind of professional might be consult or member of your team when dealing with your environmental concern. Press on each of the following to explore them further. Keep in mind your ecological issue and consider which career might best serve your team. Chemist. Chemists taking a sample for analysis on a
Analysis on a
Navy
Navy
ship.
ship. Basically, they have to analyze a lot of things in everywhere. For example, on a Navy ship, you take samples of, like, say, water for the people on board to drink. We need to see if the water is like of good quality. It's
Like,
not
is it safe
contaminated with
or
anything. It's not like dust or you know not
poisonous?
dust or poison in there. It have to be like drinkable. So from time to time, chemists have to take sample for analysis. They take sample for analysis, like when they go to supermarket, they take random samples of food and drinks too.
Yeah. K bike high industrial and technical chemist love my bike and hikes. I work on a wide variety of projects. Much of my work
Projects.
is in the
Much of my
field,
work is in the field.
testing equipment or analyzing sample to monitor operation. Many of my colleagues work in university or industry research lab to create new material and at time it fun permit explore new theory in science. Chemical engineer. Hybrid fuel race car in a race. A chemical engineer helped design the fuel system for this car. Cars, more car. Chemical engineer. Passion for cars, model and real life. Simply, but I developed ways to turn raw chemical into useful substance. For example, transforming crude oil into natural gas. This required knowledge of both chemistry and engineering. At the present time, I am in the oil sand industry, where much of the work is design, construct, and operate extraction plants. We are constantly developing new ways to extract the oil using less water and producing less contamination for the betterment of society. Health environment focus. I say we because I often work in teams with constant change in technology. My
Well, it's
work
forever
is
changing and
for
evolving. Of course, it's forever changing and evolving.
I am envious of chemical engineer like my brother who are working on space, travel and vehicle. New products like a race car that runs on hybrid fuel or car that operate alone.
Alone at the present time.
He is working for one of the automobiles company
Automobile
exploring
companies exploring vehicles for future.
that reduce our carbon footprint.
Hmm.
Environmental chemist. To decrease habit of an open pit mine, environmental chemists will help restore this mine site to its original natural state. Tree hugger. Environmental chemist.
Tree
Tree
hugger.
hugger 24/7.
Mhm. You know, when people do mining, they destroy their neighboring environment a lot. When they,
Like
because of all the chemical, all the activity that they do, it degrade the habitats. So open pit mines, like when you extract things like ore or iron or gold or any kind of metals deep inside of the rock layers, you also destroy the habitats of a lot of animals and trees. You know, on the
because the
surface.
chemical are like leaking out of
Exactly.
the ground
It leaks out. It can damage the river surrounding it.
and the water be like contaminated. As an environmental chemist, I analyze the soil and water to find out what contaminants are present and suggest ways to remove them. I also help with the design of the landscape to ensure the chemistry of the entire environment around the site is restored to its natural condition. Most of my work is research based through one of the major universities in Canada. When I am not in the lab or out in the field, I volunteer my time to chemists without borders who are throughout the world, making a difference throughout the world.
Mhm.
Biochemists. This picture is two
You know
biochemists.
what? Biochemistry is a horrible subject. It's extremely hard to understand, and there's just so much jargons or terms to learn, and weird chemistry involved. It's just terrible. Biology, it's
But,
okay. Chemistry is excellent, but when you combine bio and chem together, it just
but you get paid well, right?
yes, because we in this COVID-19 pandemic, well, there's a high demand for biochemists and biotechnologists. Anything bio related, anything like biotech related.
Two biochemists examining the analysis of
Some
some
genetic
genetic samples.
samples.
H's food. Biochemist for Healthier Paper Food Ltd. The primary focus of our work is on the molecules that make up living things. This field is expanding rapidly. At HHF, we do research to discover and create healthier food. Our daily tasks vary, but for the most part, we are researching
And
and
product
product
testing, yeah.
testing. Some of our colleagues from university classes together are discovering new medicine and are often consulting with doctors, consulting patients, and running their own company or businesses.
Hmm. A lawyer with a major
Lawyer,
chemistry. Oh, we have a lawyer with a major chemistry. Like, for example, if there are any kind of cases that people sue each other that is related to like chemical spills or like chemical damage or chemical attack or something like that. A lawyer with a major in chemistry, they will understand exactly what he should do, what is the damage, and what is the how can I say the law against such an attack or such a damage. Otherwise, they wouldn't know. So, lawyer with a major in chemistry, it's just like it's very suitable for those kind of cases where people sue each other for that. For example, what's that noise in your background?
oh sorry, it's like construction.
I'll try to reduce that noise afterward. Don't worry. Anyway,
Alright.
so when people spilled chemical on, let's say, the ocean, and then people sue those companies, these lawyers are going to be the one who defend those companies.
Yeah.
Or it depends on who hired them with a higher price, of course. Lawyers are just there to exploit the loopholes in laws and to help their clients to win in the court of justice, you know. So whoever
Yeah.
pays them more, yes, like that.
It's like when you fight for something, like a lawyer's there to protect you or help you, like can be
No,
illegal.
sometimes it depends. It depends who pays them more. If you think the lawyer protects you, no, not really. They just protect who pays them more. That's the thing. That's a reality.
Yeah.
I mean, in reality, it's always like that. Especially in America, if you think about the law system, just horrible. Someone's saying, talking in English, huh?
Wait, hold on.
Can you just close the door or close the window or tell them to just.
Okay. Can be legal. Corporate lawyer with a chemistry degree. More and more companies have to deal with complex chemical issue and they have to comply with new environment law that deals with chemical pollution such as oil and greenhouse gases. Therefore, lawyers with a degree in chemistry like myself are in high demand because we understand the chemical issue involved and can advise company legally. MBA with a dual degree
Dual
in
degree in chemistry. Young scientists working more in laboratory.
people with chemistry degree are hired as
Consultant.
consultant to work with analysts and investor looking to
Looking to
invest
invest in
in
a
it.
technology company.
Most new technology involve using chemical in some
Some
important
important
way.
way.
Investors need help understanding how the chemistry work and whether the technology will be useful.
Be successful.
Here's where I fit in. As I have a business degree with a technology focused and chemistry degree, I can explain the chemistry, understand the business sense of the investor,
Mhm.
and know the technological language used in today evolving system.
Mhm.
I work independently as a consultant and have not been out of work since I graduated.
Because basically she involves like she has like dual degree like in relevant fields, you know, people need it. So that's why she have not been out of work since she graduated, and I'm sure she makes good money.
Yeah.
And of course she can support herself well. Now let's go on. Scientific methods.
The scientific method. Science advanced because people do experiments and other kinds of research and then share that they
They
have
have
discovered.
discovered. Share what they have discovered.
It's like sharing the knowledge that to the world.
Mhm.
One of the most important parts of this process is communicating what is found so that other can build on what the research has concluded.
Concluded.
Over the
So
years, science
basically, what you have found, you have to find a way for others to continue your research in case something happened to you, or in case that
and
the others want to follow your research. You know, you have to find a way to for so that the others can replicate what you do.
to help
So
the world. Over the years, scientists have worked out out the best way to communicate the result of their experiment. In Unit 1, you were introduced to the lab report format when testing soil resistant to erosion.
Erosion.
Throughout this erosion, throughout this unit, you will continue to apply this
This format
format
is
as
chemistry too.
laboratory reports are written so that someone else can repeat the experiment if they want.
Hmm.
All the information about what was done and how it was done is explained. It also explains why the experiment was concluded, what happened, and what the result could mean. The process of asking questions, creating hypotheses, and then testing them is known as the scientific method. Let's take a look at how the scientific method is applied when conducting an experiment. What if you had a mixture of iron filings, sand, salt, and pebbles, and you wanted to separate it into its individual component? Brainstorm some way in which you could do this. Here's an example of how the scientific method could be applied to separate this mixture, present in the format of a lab report. Ask question, do background research, construct hypothesis,
Hypothesis.
yeah, test with an experiment, analyze result, draw conclusion. Hi, hypothesis is true, report result. Hypothesis is false or apparently true, think and try again. What is a laboratory report? The title of a laboratory report is short, informative statement explaining what the laboratory report is about. Purpose. This is a short statement or paragraph explaining the reason for conducting the experiment. The goal of the experiment is to separate a mechanical mixture using only phy- physical method. Hypothesis. Hypothesis is an educated guess that predict the result of the experiment you will be conducting. It is written in the form of a prediction. Example: a mechanical mixture can be separated using only physical method. Material. This is a list of all material used in the experiment. Diagram can also be used in this section to show how the experiment was set up. Example: in my experiment, I use
Mixture sample
mixture
of sludge scooped from a stream bed. Oh my god.
chemicals.
A stream bed means like you take it from a lake, like a natural stream of water in a forest or something, and then it's like you scoop it from like very low, like the sand and the water together, scoop it up. It become a piece of like something scoop, like a sludge, and then you put tap water into it, 500 milliliter. You need heating plate, 3 beakers, and then a half a liter Ellen Mayer flask, wax pencil, and then electronic scales. Okay, these are all the things you need. So
Let's just take example.
basically, I think the experiment is to test like the chemical composition what's in there, what's in the sludge of a stream bed. Mm-hmm.
Hmm. Method. The method are an order list of steps clearly describing how the experiment was done. They are written in the past tense and are usually written in the third
Third
person.
person.
The
You
mixture
know
was
why?
passed.
Because basically we don't want to say who did the action or who's responsible for the action, because that would be redundant. We don't want to say it all again, like let's say the student mixes this with that. The student passes the gas into this tube or something like that. You don't
Yeah.
want to always mention who did the action. So that's why we use a passive form, past tense, or something like the mixture was passed through something, instead of like I passed the mixture through something. So
The,
it's a process. You use more passive voice or you know, the passive form.
example. The mixture was passed through a sieve and onto a paper towel, and the pebbles were placed in a beaker. The magnet was passed over the surface of the remaining mixture, and any iron filling that attaches to the magnet were removed and placed in a separate beaker. This was repeated until no iron filling were attaching themselves to the magnet. The remaining mixture was placed in a beaker and water was added to 500 millimeter mark. The mixture was stirred with a stirring rod un- until the salt was fully dissolved. A polar filter paper was placed in a tunnel. The tunnel with the paper was placed in the aluminum flash. The mixture was poured through the funnel,
Say again.
making
The
sure.
mixture what was stirred, and a stirring rod until with a stirring rod, like stirred
Yeah.
until the salt was fully dissolved in there.
A folded filter paper was placed in the funnel. The funnel with the paper was placed in the Erlenmeyer flash.
Mm-hmm.
The mixture was poured through the funnel, making sure that it passed through the filter paper. The filter paper containing sand was removed to a beaker and dried. Any remaining sand was dusted off the filter paper and the filter paper was thrown out. The water in the aluminum flash was placed on a hot plate and
Hot
boiled
plate, yeah.
until the flash was dry and all that remained in it was salt. Salt. This section tells the reader what the experimenter saw before doing and after the experiment. It is usually organized into sections including diagram, table, and graph. The result may be in quantitative, involving number, or qualitative form, not involving number. All quantitative information recorded must include units of measurement,
Such as
such as
gram,
gram,
meters, meters, or meter in American English. Meter or meter
meter.
is the same thing, or degrees
Yeah, meter.
Celsius. I don't know why America has to be different from the rest of the world. We use degrees Celsius. They use Fahrenheit. I was like, what? And we use meter. They use foot.
It's kind of confusing.
It's very confusing, and it's not useful. Let's say it. It's not useful at all. Now, so the result may be quantitative, like how much, and qualitative is like how. Qualitative, like what do they have? What do they have? But quantitative is like how much do they have? So these are the two things that you need to keep in mind: quantitative or qualitative. Okay.
Okay.
All right. Please continue. Let me take a break first.
In the washroom.
Okay. Okay. All right. Let's continue. Peoples and things like that. Now, laboratory report.
Experiment. In my experiment, I observed that the mixture was a light gold color with speck of dark silver metal filling. The pebble was a spotted brown color. Some of the mixture was left over on the paper towel. The filter was not completely clean before being thrown out. The water evaporated from Erlenmeyer flash
That's 100
at
degrees Celsius.
100 degrees Celsius, leaving a white salt residue
It's
on the
called
wall.
residue. Residue.
Uh, residue
Residue on the
on the
walls and bottom of the flask. Residue. Residue is
residue.
basically what left over after everything else has gone. You know, residue. Okay,
Analysis.
analysis.
This is a section where you can include any calculation you perform and discuss your result in detail.
Examples.
I was able to separate the provided mechanical mixture into their component based on the sorry,
So yeah,
offer
based on the
based on the
observation. Observation.
observation. Sorry.
It's okay.
The separation seems successful, but because of the lack of quantitative
Quantitative.
information,
Quantitative information.
oh, quantitative,
Like how much? hmm
yeah,
How much salts
it-
and iron filings.
how much sand, salt, and iron filling we started with. We are unable to determine the accuracy with which it was done. Separation of the pebble was based on their size.
The pebbles was based on their size.
Pupils. The pupils were larger than the other particle. We could use a
A
sieve to
sieve to
collect.
collect them. You know what a sieve is, right? A sieve is like it's a kitchen utensil. It's a kitchen thing. So people can put thing on the sieve and they will capture all the bigger stuff, and then the water will just flow through the sieve. You know,
Yeah.
it's a filter. It's a kind of filter in the kitchen.
I think the rest of the mixture passed through the second separation was based on the fact that iron filling are magnetic.
Magnetic.
They were attached to the
Attracted.
magnet
They were attracted to magnets and could be removed easily.
and could be removed easily. Water was added to the remaining mixture of salt and sand. Since salt dissolves in water and sand does not, I collect the wet sand using a filter paper
Inside a funnel.
inside a funnel
A funnel. A
to
funnel.
remove a funnel, sorry, to remove the water and get the salt on its own. It had to be evaporating
Evaporated is the boiling point.
at its boiling point of 100 degrees Celsius,
I think now we call it 100 degrees Celsius.
100 degrees
Yeah,
Celsius.
because everyone say 100 degrees Celsius. We don't say 100 degrees Celsius anymore. You know. I mean, it's not wrong, but it's just people don't use it anymore. So it's not natural to say 100 degrees Celsius. You know. Anyway, let's continue. Conclusion.
Conclusion. The conclusion section is related to the original
The
purpose
original purpose and hypothesis.
purpose and hypothesis. Do the result of your experiment support your hypothesis? If so, it is important to state this. If they do not, you could pose some question based on your result that could guide a follow-up experiment.
hmm
A conclusion should also suggest some
Sources
source,
error.
sources of error Even if your experiment worked well, if another individual conduct your experiment, they can take your note of your sources of error and ensure that they design it so they can take these into account. Example, the hypothesis was correct. I was successful at separating the mixture into its individual component. Using only physical method, there were a number of sources of error in the experiment. Most were small. I lost some of the mixture on the paper towel when sieving it. There was probably
Probably
some
still some
salt left
salt left over in the wet sand.
to, together with the water.
Mm-hmm.
I also lost some sand on the filter paper. Overall, the experiment was successful.
So a lot of thing was taken into account, like because you use so many things, so there might be many sources of error, right?
Yeah, so there
The
could be
more
like some
things, yeah,
leftover.
the more things you use in the experiment, the more error will have, or likely to have.
Yeah, and this is it. Is the working in chemistry is like finished.
It's arduous work. Excuse me. Not supposed to see that. All right.
See what?
No, no, nothing. Just continue, please.
Yeah,
You,
let me share
you,
screen.
your share screen just ended.
Oh yeah, because yeah, I closed it because the working in chemistry is like finished. It's like
Okay. Now let's just start screen sharing again. Yes. Okay, so describing matter now. Describing matter.
what is matter? Atoms are building blocks of all matters in the universe, from star and the sun to your body, to the clothes you wear and the food you eat.
Everything's made of
Everything is made of.
atoms.
The rest of this unit will focus on three
Specific parts of the matter around us.
specific part of the matter around us: atom, element, and compound. In this learning activity, you will gain an understanding of matter and be able to explain it using particle theory. You will review the three methods for classifying matter: state, composition, and properties. Explore the state of matter. Using the following interactive activity, explore the state of matter. Choose an atom or molecule and a state: solid, liquid, or gas. Using the heating and cooling gauge at the bottom to raise or lower the temperature of the substance. Choose three temperature and record your observation in your notebook. Using a format
Formats such
using
as the following table. What do you
what do
notice
you
about how the atoms and molecules behave?
so there's like uh this thing. Alternatively, you may choose the following accessible version of this activity. There are numerous possible to explore. However, three scenarios are provided
Provided
below.
below.
Scenario 1. Oxygen appear as two orange circles joined together. It is a solid at 31 Kelvin.
Oh, do you remember what Kelvin is? The Kelvin temperature?
Uh,
So compared to, okay, it's a scientific temperature. So compared to degrees Celsius, what is the formula to come to convert it back into Kelvin? You remember that?
It's like I'm not sure.
It's this
I don't
one.
remember.
Kelvin equal to degrees Celsius plus 273.15. So if it's like 31 Kelvin, so probably it would be about minus 242 degrees Celsius. That's when oxygen becomes solid. It is solid. It's extremely, extremely cold at that temperature, minus 241 degrees Celsius. Anyway, it's 31 Kelvin.
31 Kelvin.
Mhm.
And this appear as 10 row with 10 orange circle in each row.
Mhm.
They appear to be moving slowly, but the remaining group together when the heat is applied and the temperature increased to 122
122
Kelvin.
Kelvin.
The molecules stay in groups of two but move more quickly, with more of these groups moving away from the largest group. The group that move away do so in approximately 3 to 4 set of two. When more heat is applied and the temperature is raised to 328 Kelvin, most of the oxygen molecule move about a set of
Two on the
two on
island,
their own.
not in a group.
Uh, Scenario 2. Neon
Neon as a solid.
as, as a solid appear as single blue circle with 10 rows and 10 circles. In each row, when the temperature is 1 Kelvin, the circle moves slightly but remain together in this formation. As heat is applied and temperature is raised to 43 Kelvin, the atom move more quickly, first as a group but then individually. As more heat is applied, the temperature is raised to 100 Kelvin. The blue atoms start to bounce off of each other and the internal wall of
Mhm. Simulator.
simulator. Scenario 3. Water as a solid is displayed as one orange circle and two smaller white circles attached to it.
That's H2O. Because water is H2O. So that's why it's like two hydrogen and one oxygen. So one orange is the oxygen, and two smaller white circles are basically two hydrogen.
Do I need to like share this with you because it's really confusing for you to
Okay,
understand?
sure. I mean, if it's confusing, then you share with me so I can explain to you. Just share.
Mm,
Okay, your microphone, my phone.
there. So scenario 1 is oxygen appear as two orange, but when is
Okay, you heat it up, and then we'll see what happened.
heated up,
And you can see the temperature increasing slowly. Not that slow, it's actually increasing quite fast. You can see that it's dissipating and becoming more and more separated, isn't it?
yeah.
But then
So
as the
that's true.
temperature decreases now, it comes together again.
X is for so the neon is like separating. Oxygen is combining together.
Okay, and then you try to decrease the temperature. You can see that it clumps together and it may become like even solid.
Yeah. And the water
It's
is
always like that, you know. There's some space between them because they are liquid, of course. But when you cool it down, it's still the same. When you heat it up, it would just
and
go everywhere. What makes you not
argon.
understand it? What makes you not understand it? Tell me.
Um, it's like how they separate. It's like the heating up
Of course, when you
process
heat
or
up,
the
when you
cooling
heat them up,
process.
of course, it breaks the correct. When you heat it up, it breaks the connection or the bonds or the interaction between them, right?
Yeah.
So of course, when that interaction is broken, they will just spread around randomly.
Scenario 2. Neon as a solid appears single blue circle with 10 row, 10 circle in each row when the temperature is 1 Kelvin. The circle slightly move slightly but remain together in this formation as heat is applied and temperature is raised to 43 Kelvin. The atom moves more quickly, first as a group but then individually. As more heat is applied and the temperature is raised to 100 Kelvin, the blue atoms start to bounce off each other and internal wall of simulator. So
Mhm.
it's like when you heat it up to a lot, things start moving it slightly and then it start bouncing around. And for scenario 3, water as a solid is the place that one change, one orange circle and two smaller white circle attached to it. At 157 Kelvin, the molecule is a solid and appear to vibrate as set, most likely at the bottom of the simulator. When the heat is applied to and the temperature is raised to 820 Kelvin, the water moves more
When you
quickly with
try it to
some
increase
spinning.
it to that temperature, you will see. Just heat up, and then when
So,
it reaches that temperature, you will see.
so, so
Just heat
at
up, and you will see. Okay, it cools down. It becomes solid now. It becomes more and more solid now as you
when
increasing
you
it.
when you
Heat
increase it,
up,
it
and
was
then which is basically everywhere now. Wait,
just like bouncing.
it takes some time for it to bounce around, you know.
Yeah.
Okay,
Now I'm just gonna go back to
just
the
continue to another part.
action. Particle theory of matter. Matter is anything that has mass and occupies
Occupy
space.
space.
State of matter can be explained by the behavior of the a
Particles.
particle in the seven in the
700. Daniel
7,000
Bernoulli. Bernoulli. Bernoulli
Daniel
principle.
Bernoulli.
Have you heard about Bernoulli principle?
It's like
About a flow, I think. As I remember, Bernoulli principle.
the newly principle. It's like in the it increased the speed of a fluid occur simultaneously with a degree in pressure or decrease in the fluid potential energy.
Yes.
Daniel Bernoulli, a Swiss mathematician and
Mathematician. It's like a and physicist.
physicist, tests a hypothesis that a gas is a type of matter made up of invisible particles that move very quickly. Other who tests his idea through
Who tested his idea through
experimentation
experimentation.
all made the same offers observation.
Observation. Observation.
Bernoulli's
Bernoulli's idea.
idea became the basis for particle theory of matter. The
Just the
particle theory
flow
of
of
matter,
particles, you know.
yeah, it's like
You haven't told me when you have your exams in math.
it's like exams. I think we can worry about it like later.
Okay, sure. Okay, you lead your way. You lead the way, though. Be proactive. I'm just helping you here.
Particle theory of matter help us visualize what matters looks like and how it behave in three different states: solid, liquid, and gas.
But it seems to me that your mother is like put all the trust and all the responsibility on me. So if you score badly, I'm gonna be the one affected.
Oh my!
So you
Now
have
we
to be the
keep
one planning your study very well, you know. So I'm just here to help. Now, let's continue. Particle theory of matter. Three common states.
in a solid, the particles are held close together by a strong attractive force. The particles have little energy and cannot move beyond vibrating in place. Particles are so densely packed in a solid that they cannot be easily pushed together or compressed. One of the main characteristics of solid is that they have both a fixed shape and volume. Liquid. The particles in liquid are still attracted to each other, but the force of attraction are not strong as they are in a solid. They have a little more energy
And are therefore farther apart. Uh-huh.
and both can vibrate and move more easily.
Mhm.
Liquid do not have a fixed shape and can
They just
therefore
they
flow.
just flow like randomly on each other. It's like a
It's like moving freely.
yeah, exactly. They move freely, very freely.
They do, however, have mixed volume since the particles are still fairly tight packed together and cannot
Cannot be
be
easily
easily
compressed.
compressed.
You cannot just compress it easily. Of course, gas you can compress it easily, but quite easily. But no, not liquid. Solid you cannot even compress it further. I mean, of course, in theory you can compress it, but it require a lot of force, like a tremendous amount of force is required for that.
In a gas, the particles have to no force of attraction and therefore move independently of one another. They bounce against each other and are in constant motion. As a consequence, gas have neither a fixed volume
No
or
shape.
nor shape.
Because they move freely, they don't have a fixed shape at all. And so because they move freely, they go far apart from each other and then bound boom, to each other. So it's like they don't have a fixed volume because the volume can expand or decrease. It depends on the container, right?
Yeah,
It depends on the container that keep those gas. They don't have a fixed volume, or they don't have a fixed shape either. Of course, they take the volume and the shape of the container they're in. But if you open the container, they would just spread everywhere, you know.
spread everywhere and just like
Now changing states.
Changing state. Many substances can change their physical state to cause a change in state. You either need to add or remove energy in the form of heat,
Hmm.
increasing the temperature and therefore energy
Energy.
of a substance cause its particle to vibrate more quickly and move farther apart.
Hmm.
Removing heat energy by decreasing the temperature causes the particle to slow down.
Okay, I mean, changing state. This sentence, I mean, this part is important to reread again and then look at the picture on the right. This part is important. Please spend some time on it.
Okay.
Like you need to know what is the state changing's called. Melting, freezing, condensing, boiling, sublimation. It's basically from solid immediately become a gas, and deposition is the opposite. So gas becomes solid. You need to know all of these six states carefully.
Mm.
What is what? Hmm.
Heat is added to solid, turning it to liquid.
You have to choose.
Melting.
Hmm.
Heat is added to liquid, turning into gas. Mm. This one is. Um, this one is evaporation.
Very good.
Heat is removed from gas quickly from gas, turning it into solid.
Gas to solid.
This one is deposition.
No, deposition.
Oh,
It's like
deposition.
it deposit from gas, it become quickly solid, so it deposit into something, deposition. Heat is added quickly to solid, turn into gas. It's the opposite.
Is added to a solid, turning it into gas. So it would be sublimation.
Yes, very good.
Heat is removed from a gas, turning it into a liquid. This one, heat is removed from a gas, uh, turning it
Gas to
liquid.
liquid.
This one should be con- condensation.
Condensation. Exactly.
Heat is removed from a liquid, turning into solid. Freezing.
Hmm. Very well. I think someone is also studying online now. It's not just you, it's your brother.
Yeah. Classification of matter. To
Classification matter.
study, sorry, to study matter, scientists must be able to classify it, placing it in a specific category. You have already seen one way of classifying matter, its state. Most substance can be classified as a solid, liquid, or gas, but there are some situations where classification is not so straightforward. For example, did you know that milk is a mixture of solid particle suspended in liquid? Scientists need a new way to classify matter that solves this problem. All matter can be placed in one of two categories: pure substance or
Pure
mixture.
substance. Pure.
No, pure substance or
Pure
mixture.
substance or mixtures. Yeah.
There are two types of substance: element and compound. and the and two types of mixture, heterogeneous and
Heterogeneous and homogeneous.
homogeneous. Here is a flow chart you can use to reclassify any substance. Take a closer look at the different category and
The
characteristics of each
characteristic of
one.
each one.
Solid, liquid, gas. Pure substance, constant composition, separating individual component. Mixture, preparating mixture, variable composition.
Preparating mixture. Variable composition. So because it's a mixture, it's like it mixes different things in there. So it must have variable composition, of course. You know, like how many percent of A, how many percent of B, how many percent of C, something like that. And when you talk about pure substance, because it's pure, it's just 100% of something, right?
Yeah.
So it must be constant composition, just 100% of something. And when you talk about mixture, you have homogeneous mixture and heterogeneous. Homo mean the same, hetero mean different. So homogeneous mixture is when the mixture they mix together very well. They don't separate out easily. You know, they mix together very well. But when you talk about heterogeneous mixture, they separate out after a while. You know, because they don't
Yeah.
exactly mix. Like for example, sand and water, they are heterogeneous mixture. They don't mix. After a while, they will be like separate into two layers. But like water and salt, they mix very well, so you have a homogeneous mixture.
Pure substance. Pure substance can be
Pure.
classified as element or compound. Element that are made up of
One kind of
one
atom.
of kind of atom, whereas compound are made up of molecules.
Hmm.
Different atoms
Chemically,
together, chemically bonded together, sorry,
chemically bonded together.
and can be only broken down into their individual atoms throughout chemical reaction.
Hmm.
A mixture contain two or more substances placed together
Substances placed
that do
together.
not chemically react with each other. For example, you put some salt and pepper on a plate and stir them around you. You have a mixture. There are two types of mixture, homogeneous and heterogeneous. Element. A pure substance cannot be broken down any further are called elements. Some example of element include helium gas used in balloon and carbon, a dark substance found in graphite
Graphite,
pencil.
graphite,
Graphite pencil.
graphite are pencils, like pencils. In the tip of the pencil are basically the graphite. Basically, it's also carbon too.
Compound.
Okay,
Compounds are
remember their definition. Okay, compounds are made up of two or more different atoms bonded together. So it has to be two or more. Okay, to become compound. Like for example, CO2 gas, CO gas, H2O is water, something like that.
yeah made of two or more different atoms bonded together through a chemical reaction.
Mhm.
An example of a compound is water. It is made up of two hydrogen and oxygen, chemically bonded together in their
Chemically.
original state.
Mhm.
Hydrogen and oxygen are both gas, but when they bond together, they form a liquid. Heterogeneous mixture. A heterogeneous mixture contains two or more substances that result in visibly different parts that are not evenly mixed. For example, if you add olive oil to water, a mixture of two clear layers is visible.
Mhm.
The oil is lighter than the water, subtle on top of it. One type of heterogeneous mixture is a suspension. A suspension consisting of tiny particles of one substance suspended
Mhm.
in a liquid. It's called a colloid
A
or
what?
colloidal
Colloid.
suspension.
Colloid is basically glue. Just remember, just think of it as glue. Like glue. The glue that you used to use in use in the classroom. To stick things together. Glue.
Yeah.
Colloid is basically glue. It's like glue-like substances. Glue.
So it's like you just like it's not fully mixed. It's just like on top of
Yeah, it floats
something.
on top of something else.
Milk is an example of a colloidal suspension. Milk looks like a solution, but it's actually a mixture of liquid water and solid milk fat particle. The salt never dissolve in the water but float in it. Instead, with many liquid suspension, over time the particle in suspension tend to separate from the liquid and settle into different layers. Homogeneous. Homogeneous mixture solution appears uniform throughout. That is, you cannot see the different substance it is made of. Salt water is a liquid homogeneous mixture.
Mhm.
It contains salt and water that have been mixed together so well that you can't see them as separate substance.
Mhm.
Air is another example of a homogeneous mixture. It contains different types of gas, such as oxygen, carbon dioxide, and nitrogen, that cannot be
Distinguish from one another.
distinguished from one another. Homogeneous mixture
Homogeneous mixture.
can be separate by physical means. For example, a saltwater solution can be separated into individual components throughout evaporation. When the water boils and evaporates, the salt is once again visible as a crystalline substance.
Mhm.
Can I take a little break?
Sure. Right. Okay.
Self-check classification of matter. What is the main difference between heterogeneous and homogeneous mixture? Genius is contain two
Yeah, brother. Okay, so let's just read through it a bit. Now, hello, are you still there?
Yeah, I'm still here.
Okay. Contain two more substances. It's not fully mixed. Homogeneous.
And
There's a huge problem with grammar in the sentence.
oh, sorry,
Homogeneous mixture, it's fully mixed. Okay.
is fully mixed and you
Cannot be separated easily. Yeah.
separate
Cannot separate easily.
the
Cannot separate easily. Easily. I think you need to really focus on improving your grammar too.
sorry.
I do. I mean, I have like a grammar book. I can show you later if you want to. It's important to improve your grammar, you know.
Classify the following eight substances as either a homogeneous mixture or the heterogeneous mixture.
An element or compound.
An element or a compound. Helium gas. Helium gas. Oh, helium gas.
Just helium itself, right?
Yeah, so
So what is that then?
I think it's element.
Mm-hmm. It is.
Mercury inside a thermometer. And the compound.
No, it's not. It's an element. Because why? Because thermometer is made of glass, right? And it doesn't
Yeah.
mix anything with mercury, so it's not a mixture. Uh, Basically, mercury is just Hg. It's just one element itself. It's just one element. So
Oh,
I think it's element. No.
carbon dioxide.
What is that then?
So carbon dioxide. Carbon dioxide is I think it's a compound. Water and sand is milk is a homogeneous mixture. Sugar salt is sugar water. Cake mix is table salt is physical and chemical property of matter. So far, you have seen how
Physical and
matter
chemical
can be.
properties of water. You know, water is a very special substance.
Yeah,
It's a very special substance because basically, like for example, at 4 degrees Celsius, it has the biggest volume, but when you drop down to zero, it's like it has a smaller volume and becomes solid. I mean, at 4 degrees Celsius, it has a bigger volume. It has the biggest volume, but it's still a solid. It's still a liquid at that stage, but it has the biggest volume. I think. As I remember, there's something about 4 degrees Celsius with water, and
yeah.
it's much. It's very weird compared to a lot of other substances. Water is so different at that aspect at 4 degrees Celsius. Something about that you will see.
Mm. So, so far you have seen how matter can be classified in two ways. The first is by its state, and the second by its composition. We are now going to explore a third way to categorize matter. It's probably how it behaves. The properties of any substance can be divided into two distinct categories: physical and chemical. Physical property physical, physical property can be observed without changing the identity of a substance. Although you may change its state, the physical property of a substance include characteristics such as color, brittleness, and density, among others. Another physical property of a system is boiling point, the temperature at which a liquid will vaporize, for example. Both liquid, water, and water vaporize are the same substance. Water vapor can be condensed into liquid water, and liquid water can be vaporized into water vapor. In general, physical change are easily reversed. Chemical property. The chemical property of a substance are related to chemical
Chemical
changes, reaction that cause a substance to become a different substance. These properties include things like how easily a substance can burn and whether or not it reacts with other substances such as acid. Chemical change involve the creation of a new substance, so they are not easily reversed. An example of chemical reaction is when the metal iron react with the oxygen in the air to form a new substance called iron oxide, rust. In some cases, the new substance that form is gas. For example, when bread rises, air bubbles get trapped in dough, causing small pockets to form. This makes the dough lighter or more spongy. One, it is big. When a piece of magnesium metal is placed in a test tube of strong acid, hydrogen can be seen bubbling
Just
in
like
the
that
tube.
bubblings, yeah.
So it's like some example of chemical properties include absorb or give off heat during a reaction, burn easily, form a gas during a reaction or when heated, react with acids or bases, react with water, change color during a reaction. Copper is stressed into thin wires. Physical, physical copper is dye, which means that it can be easily be stressed. Dough fries, chemical. Gas is formed when dough fries, causing the bubble to appear
That's
upon
exactly
dry
what we. That's exactly what people do when they bake. You know, when they bake bread.
bread.
So basically, when they just knead the dough, and then they mix them with a baking powder, and then after a while, the reaction occur. It produces gases, so the dough just it become like bigger. So the piece of bread is just they become much bigger because of the gas form when the doses rises.
Hmm. A puddle dry up after a sunny afternoon.
Hmm.
Physical. The sun will heat the water in the puddle until it reaches its boiling point and evaporate. Wood turn to ash when burned. Chemical.
Because when you react the wood with oxygen in the air and it burns, it becomes ash. It's a
Mhm.
reaction between oxygen in the air and wood, which is carbon. Wait, ash is basically a lot of things in there.
Okay.
New substance ash. Banana turned to brown to being peeled.
Banana turn brown after being peeled. Chemical. A banana exposed to air react with it and this causes a new brown substance to be formed.
Mhm.
Purpose. Recognizing physical and chemical change in an apple. One thing it happens. Zero. Small apple, small plate, cutting board and knife. Using the lab report to write your result, explain your observation, and write your conclusion. Make sure to click save as PDF, and you are finished. Notes when writing your result, determine the type of change you observed, chemical or physical. Provide evidence to support your decision. When writing your conclusion, note whenever your observation match your hypothesis. If not, explain why you think this happened. And these in this learning activity, you learn the difference between physical and chemical properties. Be sure to have record these important concepts in your notes. You should also have recorded the particle theory of matter and the definition of physical and chemical change.
Changes.
changes. Sorry.
Mhm.
Finally, make sure that you have made a chart showing the classification of matter and check.
Check that you can define each term.
Review the notes that you have taken so far in this unit, how you recognize, how you are organizing your notebook, what strategy are you using, what that are working for you. Explore other sample of the note taking that might
What might you
change.
change or add and why? Okay, so core note taking. Basically, they tell you how you can take notes.
Number one, use two column. Use left side for Q or a question. Use the right side for information related to Q or question on the left. Use the summary section at the bottom to record big ideas and quick reminder when you are reviewing your notes. The idea behind this method is that you can cover up the right and use the cue and questioning to prompt your thinking. Visual note taking. The learning
Incorporate visual
incorporate
and text with text you understand concepts. Of course, sometimes you can just incorporate like pictures, and you can just draw things in there to help you visualize things better. You know, a lot of people, like for example, you and me, we learn better with pictures. So maybe it's better just draw things. You know.
and that's all to the describing matter.
Mhm. Wait, there should be more, isn't it?
No, that's all.
Okay, alright, so let's just end there. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh để đăng ký kênh á, để mà các bạn có thể được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.